Hello ladies and gentlemen, welcome to my video. This is another question, limits and integral. So we are going to solve the integral before the limits. But we will start the solution using substitution method so that we do not have natural log rather than exponential functions. And then using power series or exponential function for further manipulations. Define t equals to natural log x. dt over dx equals to 1 over x. From t equals to natural log x, we can get x equals to e power t. Therefore, dx equals to e power t dt. For the new integration bound, when x equals to e, t equals to natural log e, which is equals to 1. When x equals to 1, t equals to natural log 1, which is equal to 0. We obtain q equals to limits n approaching infinity, n multiply integral 0 to 1, e power phi t multiply t power n multiply e power t dt. Of course, we can combine e power phi t and e power t become e power 6t. According to Taylor series, e power z equals to z power 0 divided by 0 factorial plus z power 1 divided by 1 factorial plus z power 2 divided by 2 factorial plus z power 3 divided by 3 factorial and so on. Which means e power z equals to summation of k equal to 0 until infinity z power k divided by k factorial. In our case, we have e power 6t, so change the z becomes 6t. Replace this into q, we have new q equals to limit n approaching infinity, n multiply integral 0 to 1, summation k equals to 0 until infinity, 6 power k divided by k factorial, and then multiply t power k multiply t power n dt. This equation is pretty messy, so we better rearrange. First, bring out those terms without n. We have summation k equals to 0 until infinity, 6 power k divided by k factorial, multiply limits n approaching infinity, integral 0 to 1, n multiply t power k plus n dt. As for now, we would like to solve the integral first. Therefore, the summations and the limits are still there. While the integral become n multiply t power k plus n plus 1 divided by k plus n plus 1 for t equals to 0 and t equals to 1. Putting t equals to 1, we have n divided by k plus n plus 1. Putting t equals to 0, we have 0. So now we would like to evaluate limits n approaching infinity for n divided by k plus n plus 1. One easy way is to divide the numerator and denominator with n. Become 1 divided by k over n plus 1 over n. When n approaching infinity, this term obviously equals to 1. Therefore, we have a very simple q which is equals to summation k equals to 0 until infinity, 6 power k divided by k factorial. We know that e power z equals to summation k equals to 0 until infinity, z power k over k factorial, which means in this case, z is equals to 6. We are now in the conclusion of this video. Final answer of this question is equals to e power 6. Thank you for watching this video until the end. Please continue support my channel, subscribe, give a like and share my video in your social media. See you tomorrow for new video. Bye bye.